Okay, we have here today another integral from the University Math Society. This was problem number 8. We have the integral of 1 over x squared plus 1 times x squared minus 3 dx. Okay, and so the way this integral is written, it looks like it's set up for partial fractions. But what I'm going to do is just a little shortcut on that. It's going to be the same result. It's going to work the same way. It's going to be the same thing, but it's just going to go a little quicker for me. What I can do is I'm just going to rewrite this and create this part in the numerator and split it into two integrals. So we'll have, for the first one, I'm going to write it like this, with the same denominator, of course. And then for the second integral, we'll create this x squared minus 3. We're just kind of forcing this to work right now, but we need to make sure it all adds up. So we'll create the same denominator over here. Now, if we add these two integrals together, when we add the numerators together, we need to get back to this numerator, which is just 1. Now, if you add these numerators together, you get x squared plus x squared, so that's 2x squared minus 2. Well, that doesn't match this. Well, we can change it a little bit. What if I, instead of adding, if I subtract these instead, the nice thing with that is now our x squareds cancel out, so there's 0 there. But then 1 minus 3, that gives me 4. So 4 is still not 1. So what I want to do to make this work, if I multiply by 1/4 here and 1/4 here, now you notice the x squareds are still going to cancel because we have a 4th x squared minus a 4th x squared. Then distributing into 1/4, you have 1/4 minus times minus is plus 3/4. Now you're back to 1. So now we haven't changed it. But then by doing it this way, we've set up the cancellation we want because x squared plus 1 cancels here, x squared minus 3 cancels here, and we just have 1s in the numerator. So let me just rewrite this really quick to see what we have left. But now the nice thing about this is we actually have formulas for each of these integrals. So let's just look at these formulas. Okay, now we have the two formulas over to the left. Of course, the arctan formula is the more familiar one down at the bottom, and we'll use that on our right integral. But then we have this formula for the hyperbolic arctan that we can actually use on this one. What we can do here is instead of having a 3, I can rewrite this as square root of 3 squared. And then in this case, our a value is just going to be this square root of 3. So let's just use this to finish it off. So we're going to have this 1/4 out front. Then our a value here, we're going to want this, but we want this to be a minus 1 over square root of 3. We'll have our hyperbolic tangent right here. And then we're going to have just x over square root of 3. And then here we'll have our minus 1 over 4. Now our a value is just going to be 1, so we don't really worry about that, because we're going to have 1 over 1. That's nothing. So here we're going to have this is just going to be arctan of x. And then I'll just multiply these two together and simplify it. So I'll have a minus out front. I'll rationalize it with the square root of 3. So we can write this as square root of 3 over 12. We'll have inverse tangent here, x over square root of 3, minus 1/4 arctan of x, plus c, and that's it. Okay, good problem. Thanks everyone for watching today. Have a good day.